Hey scientists.
Hi scientists.
Hey scientists.
Welcome back.
Welcome back.
Welcome back. Did you miss us? I'm Adam.
I'm Cameron.
I'm Ethan.
Today,
We're going to teach you about forces.
Like Jedi? Almost.
Almost, but not quite.
almost but not quite.
The forces we're going to be discussing are rooted more in science than in fiction. In today's video, we are going to discuss the four types of forces responsible for holding our universe together. Gravity, electromagnetism, and two forces called strong force and weak force.
Wow.
Wow.
Amazing.
Amazing.
Amazing. Let's get into it. The first force we're going to discuss is gravity. Gravity is the miracle force by which all things that have mass are brought together. This includes objects ranging from atoms and photons
All the way to planets and stars.
Since energy and mass are equivalent,
All forms of energy cause or are under the influence of gravity. This amazing force even acts on light.
oh my gosh, what did you just say?
This amazing force even acts on light.
It includes light?
It acts on light.
That's literally wild.
What did you just say?
That's literally wild.
That's literally wild. On Earth, gravity gives weight to physical objects.
Like an apple falling from a tree.
Gravity is also responsible for the ocean's tides. The moon's gravity is what causes them.
Well, that was wild.
Well, that was wild. One down.
3 to go.
Ready for more?
Ready for more? The next force we're going to discuss is electromagnetism.
Electromagnetism. Electromagnetic force is a type of physical interaction between particles that are electrically charged.
Electromagnetic force is a type of physical interaction
That occurs between electrically charged particles. The electromagnetic force usually exhibits electromagnetic fields, such as electric fields, magnetic fields, and light, and is one of the four fundamental interactions.
by acting on the electric charge. Electrons exchange a particle called a photon. This process causes oppositely charged particles to want to interact and attract to each other, while similar charged particles tend to repel and push each other away. This is why, if you had two magnets on your fridge, you ever tried to push them together, they would just push each other around the fridge or push apart. The electromagnetic force usually exhibits electromagnetic fields, and is one of the four fundamental interactions of nature. The other three are the strong interaction, the weak interaction, and gravitation. Wow.
That was cool. The next force we're going to be discussing is a force called the strong force.
As the name suggests, strong force is the strongest of the four forces we're going to go over today.
It's 100 times stronger than the electromagnetic force.
10,000 times stronger than the weak force.
And 100 million,
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 million, million, that's 10 to the 39th
10 to the 39th stronger.
times stronger than gravity.
The strong force binds quarks together.
A gluon, the particle that carries the strong force,
Binds quarks together into larger particles like protons and neutrons.
gluons are called gluons because they keep particles together. Get it?
They keep particles together like glue.
Like glue.
Get it?
These gluons act like rubber bands when they hold the quarks together.
As the quarks get farther apart,
The strong force actually gets stronger and stronger up until a point when the bond finally breaks and new particles are formed. The strong force is also responsible for binding protons and neutrons together in the nucleus. That was some really cool stuff. Last one. Weak force.
now let's learn about the weak force.
Let's talk about weak force. Don't let the name fool you.
Don't let the name fool you.
Just because it's called weak force doesn't mean it doesn't play an important role in the world as we know it. The weak force is the force which allows the interaction between subatomic particles that causes radioactive decay. This force plays an essential role in nuclear fission.
Nuclear fission is where a nucleus splits into smaller parts.
Cool.
Cool.
I know.
I know.
The weak interaction takes place only at a very small subatomic distance.
I'm talking less than the diameter of a proton, kind of small.
Kinda small.
Wow.
That's small.
That's really small.
They might be weak.
And small, but they're good for a number of things.
The weak force allows quarks to change from one type of quark into another.
This is called changing the flavor.
Changing the flavor of the quark.
Wow.
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 Oh my gosh.
Oh my gosh.
Jeepers.
Jeepers.
Wow. Amazing.
That was a ton of information.
That was a ton of information.
Wow, that was a lot of information.
So I hope this presentation taught you a little bit more about the 4 forces that hold our universe together. Gravity, electromagnetism, strong force, and weak force.
Thanks for tuning in.
Thanks for tuning in.
Thanks for tuning in while we discussed the 4 types of forces that hold it all together.
I hope you enjoyed it.
I hope you enjoyed it.
I hope you enjoyed it.
I'm Ethan.
This is Adam.
I'm Cam.
Feel free to subscribe for more.
Subscribe for more.
Thanks for watching.
Thanks for watching.
Alright, nuclear fission is where the weak force is the force which allows the interaction to... On Earth, gravity gives... Okay. Oh god. Okay. The next force we're going to be discussing is a force called the Jedis.
Electromagnetic force is a type of force
Here we go. Take 30. Okay. This is gravity. Like, take 30. Weak force. Again. The weak force is called the weak force because, no it doesn't. No, that's not what it says. That was a little brain fart there. No, I said that all backwards. Jedis. Shut up! No. I started like 30 times. Thanks for watching. That was terrible. That was the bane of my existence.